Alright, we are working higher order derivatives, and let's look at a log function this time. Let's say, and we use some different notation. Whoa, Nelly. Okay. Let's say we'll go back to f of x. How's that? F of x is equal to, how about log 3 times x? How about that one? Well, the first thing I'm going to do is I'm going to expand this before we even start taking the derivative. And by the way, I didn't state it, but we are finding f double prime of x here. So I'm going to first off expand this. This is all part of the log properties. And we can expand this guy right up to here. Okay, we got the product. We got 3 times x. We can expand that and make sure you put a plus. Only time this is a minus right here is if this were, for example, 3 over x. Then we would put a minus. Alright, now what we want to do is take the derivative. So f prime of x. So log of 3 is just a number, okay? Constant, derivative constant, 0. Now we're taking the log of x over here, and you take the derivative of x, and that would be 1 over, and then you just rewrite whatever's in parentheses, except this time now in the denominator we are going to write the natural log of whatever the base is here, and if it's not written, anything's not written right here, then it's assumed to be a 10. So this is log with a base 10. Alright, that's the first derivative. Now let's look at the second derivative. So f double prime of x is equal to, and just for the heck of it, let's just use the quotient rule. So the derivative of the numerator is 0 times the denominator, and this is everything that's in the denominator, minus the numerator times the derivative of the denominator, and natural log of 10 is just a number. Okay, normally we'd just write that as a coefficient right over here, but it's written over here. But anyway, the derivative of x times natural log of 10 is just the natural log of 10, and of course it's all over the denominator, and this is going to be squared. Okay, let's clean this thing up. So we have f double prime of x is equal to, so 0 times this stuff here is a 0, and we're just going to be left with, it looks like a negative natural log of 10 up here in the numerator over, and we have x squared, and then we have the natural log of 10, and of course this is all quantity squared down here. Now we can reduce this down some more. So we have f double prime of x is equal to, now we have 2 natural log of 10s in the bottom, we have 1 in the top, so we can cancel one of those out. I'm going to throw that negative out here in the front, by the way. And so we're going to be left with x squared times the natural log of 10. Okay, I think that does that. Okay, so we're finished with that one, and I think I'm gonna have one more. We'll call it quits on finding higher order derivatives.